This is a download from the BBC. To find out more, visit bbc.co.uk/Radio4.
Hello, on my right, a man famous for his catchphrase, isn't that nebula lovely? It's the George Formby of particle physics, perhaps you're best known for the song, With me little bit of new graphene, along the LHC I roam. It may be one atom thick layers of carbon atoms arranged in two-dimensional hexagons, but they never complain. It's nice to have a simple method of isolating carbon atoms every now and again. It's Professor Brian Cox.
And on my left, a man who thinks that very niche reference to an old George Formby song from the 1940s will be understood by anyone in the audience. It is Robin Ince.
It was a delightful graphene-based parody of the popular hit Little Stick of Blackpool Rock, but without as many Freudian connotations as the original had. It may be sticky, but they never come... What are you talking about, George? Rock? Honestly, you're not, are you? No. So, today it is the infinite Franken-monkey cage, as we discuss the ethics, quandaries and possibilities of human beings creating artificial life.
Yes, primarily we'll be talking about the science, as this is a science programme. Ethics and quandaries sound like a department staffed by people with arts degrees.
No ethics for Brian. You should see the life he's destroyed with his botched and pointless experiments. So, to discuss this with us, we are joined by three guests. Philip Ball is a former consulting editor of Nature magazine and prolific author of popular science books, including Curiosity, How Science Became Interested in Everything, Unnatural, The Heretical Idea of Making People, and H2O, A Biography of Water, which is not the same as H2O, An Autobiography of Water, which it turns out was ghostwritten by a society of homeopaths, and runs at 57,000 pages already. Oh, water does remember a lot. And then I was on Napoleon's hat. Yes, 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 water.
Why do you always have a go at homeopaths? It's so unfair.
I'll tell you why. Do the reading. You'll find out.
Adam Rutherford is also an editor of Nature magazine, which makes it increasingly obvious that we forgot to book any guests this week and only remembered when we were drunk at the Nature Christmas party last night. Adam has presented documentaries on the cell and the genetic code and presented a Horizon documentary on the latest breakthroughs on genetic engineering called Playing God. He's a highly respected science journalist, and for that reason, we've agreed just for once not to mention his BBC documentary, Will It Snow? The conclusion of which appeared to be, it might.
But will it, Adam, will it? Tell us again this year.
The conclusion was that it definitely would snow. It's just we wouldn't be able to tell when or where.
Ed Byrne studied horticulture at Strathclyde University, but in his second year became the entertainment convener of the union, a clear sign that he only chose horticulture because you have to choose something if you're going to lie in for 3 years. Described as an observational comedian, he has also been involved on work involving quantum behaviour, in so much as he was the voice for the car phone warehouse adverts and the transistors in mobile phones exhibit quantum behaviour, certainly if you'd like to understand the band gap. Yeah.
Nice one.
He was also seen on BBC Two's Dara O'Brien's Science Club, an innovative and groundbreaking idea in which comedians and scientists come together in a chat show format in order to educate, inform and entertain. Why didn't we think of that? We beat fools! And this is our panel.
I'm afraid, Robin, the reason you didn't get the TV gig is because you don't go, at the end of every sentence. That is the crucial aspect that you need to bring to a BBC Two documentary show. Is to say something very quickly and then go, just in case anyone else was thinking of getting a word in.
Oh, dear. Ed, I was going to ask you, for the benefit of those who aren't familiar with quantum theory, can you just in 1 minute explain the application of quantum mechanics to the band gap in semiconductors?
Well, can I just first of all say that I'm feeling particularly dim today. Not just because I'm the only person here who doesn't have a degree, albeit Robin Ince's degree is an arts one, but I'm still... I did drop out, and I'm feeling exceptionally dim today because I come here surrounded by these great titans of intellects, knowing that yesterday I accidentally put unleaded petrol in my diesel car. My 2-litre diesel Golf currently sits in a garage in Haverhill, having been drained, and is immobile due to me not being able to read a nozzle.
We're off to a good start.
Well, in fact, we'll start off by asking you, Philip, which is, we are going to talk about the ideas of creating life. Now, for a lot of people, may well think that humans beginning to think about the idea of actually creating life is a very modern idea in terms of artificial life. But actually, this goes back millennia, doesn't it?
Well, we have myths about creating life. Creation of life tended to be something that gods did, of course. Some say that Prometheus created human life. And just about every culture has a myth of human life being created. But the idea that we might be able to do that ourselves also has a long history. I mean, there were certainly old stories in Greek and Roman myth of people being able to animate statues, for example. But one of the earliest examples of the idea that humans could create life comes from the notion of a homunculus. And this is something that some medieval alchemists claim to be able to make. Basically, a homunculus is a little person. It's a person. And you could do it alchemically. I could tell you how. It's a little bit rude, but most creating life is. All you need for this is semen that you put inside a glass vessel and seal it up and put it in horse dung and leave it there.
Check.
40 days and 40 nights. And after that long, you have inside the vessel, you have a little transparent being. And this being is intelligent, needs to be educated. You can bring it up like a little child. And there's your homunculus. And people believed that you could do this.
Can I ask, how could such a belief be sustained for very long when it's quite easy to demonstrate that it doesn't work?
Yeah.
I mean, people in those days, I would imagine, had fairly easy access to horse dung and indeed human unmentionables. So apart from getting the hold of a glass vial, that might have been... You could eat... my point is, it's easy to try this. So how did this manage to last so long, such a theory?
I guess the thing was, it wasn't intrinsically hard to believe. If people claimed that they could do this for all sorts of reasons, then there wasn't any obvious reason why that shouldn't, in principle, be possible, given just about everyone at that time believed that life of some sort was spontaneously happening all the time, was spontaneously created. It would just appear. There were, recipes for how to make bees. And this is something you can find it in Virgil, the Roman poet, that he has this, it's in poetry as well, how you make bees. And basically you kill a cow or a calf, you beat it to death, and you seal up all its orifices and let it putrefy. And after a while, the bees come out. And it was unproblematic. This was a way that people would create bees. Beekeepers would do it this way. And, of course, it happens because you get the little maggots appearing in stuff that's putrefying. So the idea wasn't intrinsically stupid that you could...
Well, I can see how that one could stick around, because that appears to be what happens. Bees appear when... Why do bees suddenly appear every time I beat a horse to death? But that would result in bees, is my point. Whereas, and I know this from personal experience, adding sperm to horse dung...
Well, I should say, by the way, if anyone would like to do all the recipes, as usual, will be on our website for the next week. So.
But Adam, how did the experimental method and science get introduced into these beliefs? So how did we go about proving that indeed bees didn't emerge only from dead horses?
Right, so the ideas that we're talking about basically all revolve around this notion of spontaneous generation, that life will emerge from non-living things. It goes right the way back to Aristotle, describing various mollusks emerging from non-mollusk type rocks. And
non-mollusk type rocks.
Yeah, rocks. They're just called rocks, actually.
That's what I love about science. It's so specific. You can't just say what kind. Well, very much the non-mollusk rock.
Yeah. That's good. It was Pasteur who came up with a real killer for spontaneous generation with a really good experiment. So the idea had persisted right from Aristotle to the middle of the 19th century, and the French equivalent of the Royal Society still considered it to be a valid question to ask, and Pasteur designed this very simple experiment which showed that if you had a rich broth in which bacteria would grow if you left it on the side, that if you sealed it off in a special swan-necked flask, so it has a neck shaped exactly the same as a swan, which allows air in but not bacteria, right, that it stayed sterile. As soon as you opened it, it cloudied up. And that was the end of spontaneous generation as an idea for the origin of new life that had persisted for over 2,000 years. Simple experimentation.
So how did that change then? I mean, the ramifications from that in terms of viewing biology across the board. I mean, once you get rid of the idea of the spontaneous creation of life.
Well, it meant... Well, that coincided with a lot of other good ideas about life round about the middle of the 19th century, one of which was natural selection, Darwin's big idea. Another was cell theory, which is the idea that all cells that have ever existed, apart from at the origin of life, have only existed as a result of budding off from an existing cell. And so you've got this sort of fusion of several ideas emerging, that life has a particular type of characteristic. It's all made of cells, it all behaves in a certain way, it's all a branching tree of life. So the idea that new life could arise where life had not been before suddenly becomes a very non-scientific idea and is ultimately rejected forever.
Well, Philip, I was going to go back a little bit. Something we've talked about when we've discussed astronomy before, which is the importance of the lens, the importance of the ability to be able to see further. In the same way, once Galileo popularised the telescope and they went, hang on a minute, the church used to tell us there were angels up there and there don't seem to be any angels, and then you have to rewrite your kind of mythology. And in the same way, I think it's Van Leeuwenhoek, is it? Or Leeuwenhoek, was it? Who his use of, in terms of microscopes, of being able to start to examine things at a much kind of a smaller scale. How important was that?
Well, what Van Leeuwenhoek found out was that there was life everywhere. Once he started, famously, he took a bit of pond water that had just been left standing for a while and looked it under the microscope and just looked like ordinary water, and he found it was teeming with these tiny little creatures. And this was a complete revelation, because it sort of implied that life, it could be anywhere. It could be all around us. It's, we can't necessarily see it. There is life at scales below which we can see. So in that sense, it kind of revolutionized the way we think about what life is, what life can be. I mean, some people felt, once they had been presented with this evidence, there's no obvious reason why it should stop anywhere. Perhaps life goes on appearing, to the level of the infinitely small. There are worlds within worlds within worlds. So, in a way, that opened up the whole question of what life can be. It was a new idea that life can exist at that tiny scale.
It seems like it would be quite a horrific discovery to suddenly realise that there's loads of tiny creatures in the water.
Well, we talked about...
Sincerely, though, it seems that to me, if I was the person to discover that, you would just think water, the stuff that you drink, the stuff that keeps you alive, is full of tiny little creatures. It's like a junky nightmare, isn't it? It's like, there's tiny little creatures inside me.
So one of the things that happened after Van Leeuwenhoek, that's the third variation of pronunciation, was that he was the first person to see human sperm, his own, in fact. He does note that it was his own, but it wasn't acquired through sinfully defiling himself.
He was the first person to see it under a microscope. I mean, other people had seen it.
Do you know what? Don't drag out this bit of discussion. This will probably make the 11 o'clock edit, but not the 4:30 one.
So one of the things that happens after Van Leeuwenhoek with his brilliant microscopes was looking at his own sperm and seeing them as individual cells, is that other people started looking at their own sperm and they saw something completely different which doesn't exist, which is a homunculus again. So this idea that there are tiny little men curled up inside the head of a sperm, and this is how new humans are created. Now, of course, they didn't see that because it's not there. But what Ed was just saying, that's quite a terrifying thought, because inside the homunculus's sperm, there'd be presumably a load more sperm with other even tinier homunculuses. And where does it go? Where does it end?
Universe on the tip of your finger, man.
Yeah, I think borrows in your testicles is more disturbing than stuff in your water, isn't it? Borrows in your testicles is one of my favourite of the novels in that series, and yet is still, much like Tintin in the Congo, one of the hardest ones to actually get.
Yeah. So is that the point? Once you accept that life wasn't created as is, so there wasn't, well, most people now accept that. You didn't get humans and chimps and bacteria. So then is that when we see historically that questions being asked scientifically about origins?
It pretty much is, actually, yeah. That because, of course, that was a question that Darwin was confronted with, and that he sort of toyed with a little bit of, well, then how did it begin? Because clearly it had to, at some stage, if it began from this primeval slime, where did that come from? And people did start to think about how that might happen. And it was in the late 19th century that you see ideas starting to arise about... They had these ideas about stuff called protoplasm, and that somehow it came from protoplasm. And what was protoplasm? And the idea was that it was just... that it's basically a matter of chemistry. that you can get life going if you just find the right mixture, the right composition of stuff. And chemists were able to analyze in great detail exactly what it was that living creatures had, which elements they had and in which proportions. And they found that often they were very similar, and there were only a few elements there. So there was clearly something about what seemed to be this particular composition that seemed to make it have life. And so people began to wonder, can we make this stuff? Lots of people believed that there was no obvious reason why we couldn't. So, again, you suddenly get back to the idea that perhaps we can. Maybe we can't, necessarily make human life, or at least, not initially, but perhaps chemically we can make something that, has the characteristics of this living matter. And then people began to see whether they could do that.
Well, yeah, and the most recent example is Craig Venter's work. Craig Venter, well, perhaps you can explain that a little bit, Adam, the fact that he is a controversial figure, perhaps the most controversial figure in synthetic biology.
Yes. So in 2010, Craig Venter published a really significant paper, but it also came with a lot of press hoo-ha and fanfare, which is something that Craig Venter is very good at. And what it was a cell that was probably definitely the first cell since the origin of life that hadn't been derived from an existing cell. So what they did is they took a cell, a bacteria with a very simple genome, which causes mastitis in goats, a minor udder infection, and took the genome out and then sequenced it on a computer and then got a DNA synthesizer, which makes DNA, and then they took that synthetic genome and input it into the shell, the chassis of an existing cell, and then fired it up, rebooted it up, and they had made a cell which hadn't been born of another cell. So this is an enormously sophisticated technological achievement. I don't know whether it's creating synthetic life. It's certainly doing something that hasn't been done before. But the press went nuts for it, of course. I remember the Daily Mail headline was, "Scientists create artificial life, but could it wipe out humanity?"
Artificial life invades our shores. How many more houses have to be built for artificial life?
Where are all these things going to live?
It so couldn't wipe out humanity, but apart from the fact that it had been modified in order to not be pathogenic anymore, to not cause disease in anything. It couldn't live outside of the lab it was created in. If you were really mean-spirited and quite good at genetic engineering, you could get it to annoy a goat.
So, Philip, there seems to be an important distinction here. There's creating new life, so out of a bag of chemicals, as it were. But then there's modifying life, creating life forms of life that wouldn't have existed without human intervention.
Yeah, and I think, in a way, and I think Craig Venter's work shows this as well, what this highlights is that we don't really have the vocabulary to speak about these things. We seem to still, we're asking, did he create artificial life or didn't he? Or synthetic life or didn't he? And there's no clear answer. There's no definite way to answer that because the boundaries have been blurred. But I think there's actually a third category as well, because I think there's always been, if you look historically, there's always been a distinction that most people have drawn between creating life and creating human life. So I talked about this method of making bees earlier on, and no one worried about it. They only worried when you started to create human life. And I think the same is kind of true for what Craig Venter's done and for synthetic biology generally, that the people have raised worries about its safety, which are quite valid worries, and that is something you need to take seriously. But no, I don't think anyone, despite the attempts of some pressure groups, I don't think anyone has particularly got worried from a sort of an ethical or a philosophical point of view about what's being done here, because we don't really have a tradition of doing that. Creating non-human life has been fairly unproblematic in the past. Creating human life is different, partly because historically, and really until the 19th century, perhaps some might say even now, you raise the question of, does this created life, this created human, have a soul? And I mean, it sounds a bit anachronistic to perhaps talk about it in those terms, but people did talk about it in those terms in the early days of IVF. Some people were asking this, and certainly you saw the portrayals of the kind of, results of that sort of work as the sort of stereotypical portrayals were of, the sort of heartless, people who were lacking a spark of humanity, the kind of thing that you now see in movies about clones. It's the same story again. So a lot of the unease that people still have about some of these things isn't so much centred around synthetic biology and creating some kind of life from scratch, or however you want to talk about it. It's more to do with reproductive technologies, which things that seem to be intervening in the creation of humans.
Do you think that scientists are helped or hindered in their desire to further our understanding by creating things like a mouse with an ear on its back? You know, that image of a mouse with a human ear on its back, I felt that, to me, sort of set things back just a little bit, because it gave voice to all the people who thought these scientists are playing God. Next thing you know, they'll be growing a dog with a nose on its back. You know, it was quite a creepy image.
So I came across this argument most recently when I did a programme in which I met the spider goat. So spider goat is mostly goat, but it's been genetically engineered to produce spider silk in its milk. So you milk it, and you extract spider silk, and you can weave it into actual working spider silk. Now, that seems absurd, but actually it's a really useful thing to do, because spider silk has mechanical properties which are stronger than almost anything that we can create. So there's the prospect of weaving spider goat silk into like bulletproof vests or things like that. But from a medical point of view, really important, because tendon damage, for example, there are two methods we have for repairing tendons, and they are either using the tendons of dead people or using bits of muscle cut out from your thighs. Both of them work okay, but not brilliantly, and neither of them are permanent. If we could weave a tendon out of spider goat... Yeah, you're not buying this at all, are you?
No, it's not that. It's the term spider goat that doesn't help you. Yeah. If you called, say, the silk goat, I think people would go with it.
There's a serious point behind that, isn't there, Philip? Because these are things... It would not be possible by conventional methods to get genes from a spider into a goat. Could happen.
There's also your use of the term by conventional methods.
What are you picturing?
Well, farming, just basic farming. The idea of intensive farming, even, it is not natural. It's not conventional. So it does come down to that thing of where do you draw the line between what is conventional. What is that? I mean, just wearing clothes or cooking your food is not natural or conventional, depending on what time period you're looking for.
It's breaching the species barrier in a way that was impossible even 30 years ago. So traditional farming has relied on the fact that two types of pig are capable of having sex with each other. Right? Now, the last common ancestor of a spider and a goat was about, 500 million years ago. So trying to imagine sexual congress between a spider and a goat is...
I mean, you say that, but...
Yes, I do say that.
Philip, do you think we'll see, I mean, have we seen in the history of science and indeed human civilization the fact that our ethics do change, that for those people who currently look at these things as being unnatural, that the playing with life is in some ways terrifying or against some form of law, that we will, as we increasingly see these practical sides, which Adam was talking about, will we see, do you think, a change in our views?
Well, I think it seems to be the case that once people understand why something like this is being done, once they see the potential practical benefits, then they're much more ready to accept it. But I think that, in a sense, what happens is that our ethical dilemmas just move on. Certainly, if you look at the way people talked about the fears that were around in reproductive technologies of the 1920s and 1930s, when people were thinking of in vitro gestation, of letting babies gestate, sort of in a test tube, if you like, the concerns that were raised then were exactly the same ones that were raised when IVF came along in the 1960s. Now, of course, pretty much everyone is used to IVF. Millions of babies have been born worldwide by it, and in itself, it seems to be relatively uncontroversial. But exactly the same worries are now being raised about cloning. Already we're talking about being able to grow, tissue engineering to grow new organs, which seems fine and seems fairly unproblematic. An easier way to do that would be to grow the whole thing at once, to grow the whole organism, all the organs at once, and they're supporting each other. It's a bit tricky to start thinking about cloning yourself, making a person and harvesting it for organs. So maybe we could do that without growing the head and the central nervous system, and just grow. And
did you hear that gasp, though?
Exactly. Now,
what if I lose an ear in an accident?
Well, OK, you could... Well, that was what the mouse was for. Grow the ear on the arm.
Also, it would have made The Island a far less interesting film. And it already wasn't great. But If it was just a load of dismembered bodies just sitting in tubes that they're trying to
I'm
escape.
more scared. The idea of loads of headless things bumping around while I'm waiting to see when I want to use its kidney. Terrifying. But your vision is... No, I prefer the mechanistic thing.
Well, you see, I guess what my point is that in looking at it mechanistically or looking at it philosophically, it's very hard to find an objection to doing that. And yet, I suspect most people feel there's something wrong in that.
Do you object to growing a headless copy of yourself and leaving it there in a vat until you need a kidney?
Or bouncing around the room?
I do not have a moral objection to doing that, no. But I don't deny it's pretty creepy. I think if I did do that, I would very quickly get a reputation.
I think it's one of those things you keep secret and keep in the cellar and go, where've the children gone? Oh, not down there.
No, but I think it'd be one of those things that people oft quoted about me. I think it'd be one of those things that, do you know he has a copy of himself that he keeps with no head, just with organs. Really? You wouldn't think it to look at him. No, he is.
Yeah, you'd have to have your head done as well, because the most important thing you lost is what if you lost your hair in an accident? So they'd have to do your head as well. So we have, as usual, asked our audience to help us out of many of these ethical and moral quandaries, and we asked them the question, who would you clone and why? And these are the answers that we've got so far. Benedict Cumberbatch. Well, you would, wouldn't you? JD?
Can you make sense of that, Ed?
Hitler/Stalin, on the assumption you can clone the dead, if not now, one day surely, as a social, environmental and biological experiment to see if they were evil due to DNA or as a reaction to contemporary society. And then I like it, called Abby, and she drew a little smiley face.
Who would you like to clone and why? Brian Cox. So I could sit in the audience and he could do all the work tonight, and that's from Brian Cox. My husband, so the decorating would get done before Christmas. That's from Sally Tully. Hear that, Sally Tully's husband?
I'd like to know why the woman feels that the clone would be somehow less lazy than her existing husband.
Surely clone a decorator.
Two guys sitting around not doing the decorating.
So, there we are. Thank you very much for all those ideas, and thank you very much to our guests, who were Ed Byrne, Philip Ball and Adam Rutherford. Next week it is our Christmas special. It's not really special, but it's just at Christmas. So we'll be investigating the virgin birth from a scientific perspective. We won't. That's just what you expect.
I want to ask Adam, actually. So, scientifically speaking, might it be possible for a virgin birth to occur without the intervention of a deity?
It happened in 2006. Komodo dragons at Chester Zoo and London Zoo went through a process called parthenogenesis, which is technically virgin births. The females gave birth to eggs with no male intervention.
Yeah. That's what they told Mr. Komodo dragon.
And is that the origin of the Christmas story?
I believe it is. I believe it relates to Komodo dragons. I was never very good at Sunday school, but yes.
And, of course, as it is our Christmas special as well, Brian will be declaring himself the new Messiah.
New.
Yeah, fair enough. He is the way, the truth, and acts both as a wave and a particle, and therefore the light. Thank you very much for listening. Goodbye.
If you've enjoyed this programme, you might like to try other Radio 4 podcasts, including Start the Week, lively discussions chaired by Andrew Marr, and a weekly highlight from Radio 4's evening arts programme Front Row. To find out more, visit bbc.co.uk/Radio 4.
Adam Rutherford is also an editor of Nature magazine, which makes it increasingly obvious that we forgot to book any guests this week and only remembered when we were drunk at the Nature Christmas party last night. Adam has presented documentaries on the cell and the genetic code and presented a Horizon documentary on the latest breakthroughs on genetic engineering called Playing God. He's a highly respected science journalist, and for that reason we've agreed just for once not to mention his BBC documentary Will It Snow? The conclusion of which appeared to be it might.
But will it, Adam? Will it? Tell us again this year.
The conclusion was that it definitely would snow. It's just we wouldn't be able to tell when or where.
Ed Byrne Byrne studied horticulture at Strathclyde University, but in his second year became the entertainment convener of the union, a clear sign that he only chose horticulture because you have to choose something if you're going to lie in for 3 years. Described as an observational comedian, he has also been involved on work involving quantum behaviour, in so much as he was the voice for the car phone warehouse adverts and the transistors in mobile phones exhibit quantum behaviour, certainly if you'd like to understand the band gap. Yeah.
Nice one.
He was also seen on BBC Two's Dara O'Brien's Science Club, an innovative and groundbreaking idea.
A song from the 1940s will be understood by anyone in the audience. It is Robin Ince.
It was a delightful graphene-based parody of the popular hit Little Stick of Blackpool Rock, but without as many Freudian connotations as the original had. It may be sticky, but they never come. What are you talking about, George? Rock, honestly, you're not, are you? No. So, today it is the infinite Franken-monkey cage, as we discuss the ethics, quandaries and possibilities of human beings creating artificial life.
Yes, primarily we'll be talking about the science, as this is a science programme. Ethics and quandaries sound like a department staffed by people with arts degrees.
No ethics for Brian. You should see the life he's destroyed with his botched and pointless experiments. So,
This is a download from the BBC. To find out more, visit bbc.co.uk/Radio 4.
Hello, on my right, a man famous for his catchphrase, isn't that nebula lovely? It's the George Formby of particle physics, perhaps you're best known for the song, With me little bit of new graphene, along the LHC I roam. It may be one atom thick layers of carbon atoms arranged in two-dimensional hexagons, but they never complain. It's nice to have a simple method of isolating carbon atoms every now and again. It's Professor Brian Cox.
And on my left, a man who thinks that very niche reference to an old George Formby.
To discuss this with us, we are joined by 3 guests. Philip Ball is a former consulting editor of Nature magazine and prolific author of popular science books, including Curiosity, How Science Became Interested in Everything, Unnatural, The Heretical Idea of Making People, and H2O, a biography of water, which is not the same as H2O, an autobiography of water, which it turns out was ghostwritten by a society of homeopaths, and runs at 57,000 pages already. Oh, water does remember a lot. And then I was on Napoleon's hat. Yes, 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 water.
Dear
Why do you
BBC.
always have a go at homeopaths? It's so unfair.
I'll tell you why. Do the reading. You'll find out.